In this video, we'll be once again looking at u substitution. There is a major difference, however, between this example and previous examples. If you're looking at this example here, you'll notice that there is a function that is on top, natural log of x, and there is a function overall where I have a division by x. Now, does it appear as though there is a function inside of a function? And the answer is no, because notice there is nothing extra inside the natural log of x, and you'll also notice that there's nothing extra inside the denominator. Keep in mind that the rational function may be the interior of the function that we're looking for. In this particular case, again, x is in the denominator, and it is inside of the rational function. So, identifying all that pieces of information, we're just going to have to try and take a guess at which is the interior. Well, if I try and let u equal to x, again the interior of the rational function, my du simply equals to dx, and you'll notice nothing in this integral really is changing, because all of the changes that I do will be natural log of, well, my x is u, and my dx is du. So you'll notice that I did nothing in changing this integration. I have done nothing in terms of making it simpler. All I've simply done is change the variable. So this particular u substitution isn't going to work effectively for us. So we're going to have to try something else. And again, the argument is that if I attempt to use a u substitution and it doesn't work, then we have to try a different u substitution because that particular method wasn't appropriate. So over here, I'm going to go ahead and try a different u sub. What if I let u equal, instead of letting it equal to the interior of a function, I let it equal to some entirety of a function. So if I let u equal the natural log of x, my du ends up being, well, the derivative of the natural log of x is 1 over x dx. So here's the important part to understand, is that it's not always letting u be equal to the interior of a function. Sometimes it's simply letting u equal to be a portion of the function so that whatever's left inside this integral happens to be my du. So if you'll notice, I'm going to go ahead and rewrite this integral as the integral of the natural log of x times 1 over x dx. So sometimes this actually works effectively such that we have two functions multiplied together, not just that we have a function of a function. And again, we're going to test u's in such a way that my du ends up being either everything that's left or at least everything in terms of the variable x that's left. You'll notice in the last two examples we could multiply this original integral by a constant. We cannot multiply this integral by any form of x. So whatever variables in here must have been here to begin with when doing the integration. But now that I see that I can do this, this is the integral of my natural log of x being u, and 1 over x dx becomes my du. And very simply, I can integrate this into being u to the power of 2 divided by 2 plus c. Don't forget, every time that you do the integration, you must do your back sub. If you have a u left in your answer, you have to back sub to what x was. So in this case, I'm going to end up with natural log of x. I'm going to throw it in parentheses and square it, divide it by 2, and add c.